Hi Geometry. So today we're going to talk about ratios and proportions in preparation for our new unit on similar triangles. So hopefully this is a review for you, but if not, prepare to be introduced to the wild, wild world of ratios. So what exactly is a ratio? Great question. It is a comparison of two or more quantities. And usually that comparison is done by division. The ways that we represent a ratio are A to B, using the word TO, A to B, using the letters and the colon, and then A to B using a fraction, such as A over B. Okay? Ratios can be simplified. And this is important for more than one reason. So let's say, for example, I have a ratio of, I don't know, let's go with 2/3. So I can take this ratio 2/3 and I can multiply it by the same value on the top and the bottom and get 2x divided by 3x, and they are still going to be equivalent, right? So all I've done is increase or decrease the values, but I haven't changed the comparison I'm making between the two, because of course we could always end up simplifying out that x again. Okay? You'll see why this is important once we start solving problems with triangles. So let's take a look at how we simplify and how we use or set up a ratio. So when we're setting up a ratio, the order matters. Okay, so if we're talking in this example about comparing trumpets to violins, for example, then the trumpet needs to go first. Okay, so trumpets to violins, trumpets needs to be first or in the numerator, and violins would have to go second and in the denominator. Right, so a music store has 40 trumpets, 39 clarinets, and then we have 24 violins. 24 violins. Seems like a lot of violins to keep in stock, but you know, maybe that's just me. So trumpets to violins, if it helps you keep it straight, which one's on top and what's on the bottom, you can always make yourself a little word key right here. T over V, trumpets over violins. And then I would put my 40 in the top for trumpets, and then that will be over the 24 violins. Now, any fraction where you want to simplify, you don't want to just leave it like that. It's not in its simplest form. Keep it simple, right? So if you think of 40 over 24, you can kind of think of that as the same as 8 times 5 over 8 times 3, right? Same thing, just rewritten in terms of a factor. And since we have a similar factor, 8 and 8, I can remove that, and our simplified form is 5 to 3. So for every 5 trumpets, I have 3 violins, okay? If it were violins to trumpets, we would reverse that. Why don't you go ahead and try number 3 on your own? Give a shot to trombones and trumpets. So hopefully when you were solving this, you got 16 divided by 40, and you didn't leave it like that. You simplified it to 2/5. 2 trumpets for every 2 trombones every 5 trumpets. Can't confuse those two. Alrighty. So let's continue looking on, and we'll talk about an extended ratio. Just like you might think, the word extended means longer than the original or goes further than. So extended is also a longer ratio. It's a comparison of 3 or more quantities as opposed to 2 or more quantities. Specifically start as 3 or more. So extended ratios are A to B to C, right? And you're typically not going to write an extended ratio as a fraction because that would just get ugly, right? So typically you're going to write it with colons. Let's take a look at a couple of examples of how we can use ratios and extended ratios to find some angles and sides, right? So here we're given that we have two complementary angles, and the ratio of those is 3 to 7. Okay, so I've got complementary angles, and the ratio is 3 to 7. Find the measures of both angles. Now, oftentimes when I'm going to be working with a problem like this, I find it's easier to draw myself a little bit of a picture just so I can see what's going on. So complementary angles, we know, or we better know, that complementary means 90 degrees. Look at my exceptionally straight angles. Okay, let's just assume they're 90 degrees. And we know that the angles relation to each other is 3 to 7. So one's kind of small, one's kind of chunky. But together, they add up to 90 degrees, right? So I know that the relation is 3 to 7. Okay, now I don't know the exact measure of the angles, but what I do know is that the measure of the angles has to be equal to 3 times some value and 7 times some same value, because that would be what would give us our equivalent ratio, right? So this lets me set up a lovely little equation, which is what, of course, what we aim for. We've got our 3x, and then I know if I add that to whatever our 7x ends up being, here's our 7x, okay, that has to equal 90 degrees, our complementary angle. And that, of course, is going to allow us to solve for our measures. All I have to do now is combine like terms. 3 plus 7 gives me a lovely and even 10x, which is equal to 90 degrees. Of course, x is equal to 9. All right, so if x is equal to 9, what are the measures of our angles? All we have to do is multiply them back in. 3 times 9 is 27 degrees. And 7 times 9 is 63 degrees. So those add up to 180, and we're in good shape. Why don't you take yourself a second and try number 6 on your own? How would you set those up? If you said that you would set this up such that 4x plus 1x is equal to 180, you are correct. And hopefully you are then able to add those together and solve. All right, so let's take a look at another one. The ratio of the measures of an angle in a triangle. Muffin Ray, sorry about that. Ratio of the measures of the angles in a triangle is 4 to 7 to 9. Okay, find the measures of the angles. So again, I'm going to draw myself a lovely little diagram. Right, I've got myself a rather uneven triangle, but you know what I mean. Okay, and the angle here is 4 times some value x, 7 times some value x, and 9 times some value x. And I know that they all have to add up to 180 degrees because of triangle angle sum, right? So our setup is going to be 4x plus 7x plus our 9x is going to be set equal to the 180 degree angle sum. So then we will just simplify and solve. You should get the measure x is equal to 9, and the measures of the angles would be 36 degrees, 63 degrees, and 81 degrees, which if you add back together equal 180. Why don't you try problem number 8? So looking at problem number 8, you would have set it up so that 11x plus 2x plus 5x is equal to 180, which would give you 18x is equal to 180, or x is equal to 10. Then it was asking you to find the measure of the largest angle, which, since we know the relation to each other, has to be the 11. So 11 times 10 should have gotten 110 degrees as your largest angle. Woohoo! All right. Moving right along, footloose and fancy free. All right. If we're looking at a perimeter one, just remember here, guys, we would be setting them equal to the perimeter, not to the angle measures, because perimeter, of course, is the sum of the side lengths. So that would be 2x plus 8x plus 9x is equal to whatever the perimeter is, which must be given as 76. Okay, I'm not going to solve that because you should know the algebra on that. All right, so last thing that we're going to talk about here is what is a proportion? Proportion. And a proportion is an equation. It's an equation that states that two ratios are equal to each other. All right, a proportion is typically written as A over B, or our first ratio, is equal to C over D, or our second ratio. And for any proportion, cross product property tells us that A times D is going to be equal to B times C. You're probably more commonly used to thinking about that as cross multiplication. So hopefully you already know cross multiplication, but let's do a couple of examples just in case. So if we're going to cross multiply to solve for number 11, which is a very straightforward question, we're going to multiply diagonally. So we have 2 times x, okay, and then we're going to set that equal to our other diagonal multiplication of 4 times 7, which is 28. Then, of course, we divide by 2 on both sides, and we get that x is equal to 14, which if you substitute it back in for x, you get 4 over 14 is equal to 2/7, which makes an equivalent ratios, okay? Just what we were shooting for here. All right, so let's try one that's a little more complicated, just to make sure that we're able to use it with binomials. And so far, they haven't given us binomials that you're multiplying together, so you don't have to worry about factoring for these, but I can't promise you that won't happen. So first things first, we're going to multiply 3 times x minus 11, and it helps to put your constant in front because you are going to have to distribute. And then 18 times x minus 20. Now we just need to distribute and solve. Right? So if we're going to distribute, we're multiplying 3 times x, which is 3x, and then 3 times negative 11, don't forget your negative, it's negative 33, which is going to be equal to 18x, and 18 times negative 20, which is going to give us negative 360. Now when you solve on both sides, you're going to subtract 3x from both sides. Then you're going to add 360, divide by 15, and you should end up with x is equal to 21.8, which if you substitute back in, should give you 2 equivalent fractions. Why don't you give yourself a shot for number 18 and see what you get? X is equal to 8.5. If you didn't get x is equal to 8.5, double check your distribution. Did you multiply 7 times x and 7 times 16? If you have any further questions, feel free to ask. Otherwise, welcome to the world of triangle similarity.